this lesson, we are going to discuss the various angle types, corresponding, alternate interior, alternate exterior, same-side interior. We're going to discuss those angles that are formed by parallel lines and transversals. And we're going to see when you have parallel lines, there are some special facts that we would know. But we have to have the lines are parallel to begin with. Each one of those theorems we have the expectation that you should be able to prove them, and you should be able to use them to create algebraic equations which you then solve to find the answers. I want to emphasize, though, the objective is for you to be able to prove. That doesn't mean that I'm going to give you the proof for all three of them. You should be able to provide an explanation on your own. The first thing we're going to start off with is the corresponding angles postulate. Now, I'm hoping that you remember the definition of the word postulate. A postulate is something that we accept as being true, and we don't need a formal written up proof for it. What the corresponding angles postulate tells us, if we start off by having parallel lines, and those parallel lines are cut by a transversal, every single pair of corresponding angles will be congruent. So this angle number 1 has to be the exact same size as angle number 3. Additionally, angle number 2 has to be the exact same size as angle number 4. Top left will be congruent to top left. Top right is congruent to top right. Bottom left is congruent to bottom left. Bottom right is congruent to bottom right. And the order in which you label the angles doesn't really matter. It's about having corresponding angles congruent. As a postulate, this is something that we will accept as being true, and we don't need a formal written proof. But we should still have a general idea why it's true, even if we don't prove it. This statement is saying if you have parallel lines, then corresponding angles are congruent. That's what all the theorem is telling us, or postulate is telling us. And we could write this up symbolically simply by saying, if they are parallel, then corresponding angles are congruent. This piece here is how I will normally reference this. If you want, you can go ahead and remember the name. This is the corresponding angles postulate. When you are using your proofs, this is something that you are allowed to use. You can use the postulate to explain why other facts are true. When I'm doing it, I'm generally going to use the symbolic logic in the purple. You're free to do the same. If you prefer to remember the name of the postulate, you can simply say the corresponding angles postulate. That is also an acceptable way to reference this. You can do it either way. Now, why is this true? Think about it this way. Suppose that we've got these two lines, and I already know that this is a 70-degree angle, and down here it's a 70-degree angle. So this is showing me my corresponding angles are congruent. What if the bottom one was not actually 70? What if the bottom one was off by a little bit, say 69 degrees? If it were 69 degrees, what is that going to do to the bottom line?
It wouldn't be parallel.
in order to make it a 69-degree angle, this line has to come up just a tiny little bit, just 1 degree higher, and so it's going to get thrown off a little bit. And visually, right now, it doesn't really look any different. Remember, lines go on forever. With this 1 little degree that's off, we're going to wind up seeing that this piece is going to come higher and higher and higher, and eventually, somewhere far, far off to the right, eventually, as it rises more and more and more, eventually they will cross. But if they cross, then they're not parallel at all. That's our idea behind this. If the angles are not the same, if those angles are not perfectly the same, it's going to force one of the lines to rise or go down just a little bit, really, really slow, slow, slow. But it doesn't matter how slowly it falls, eventually it's going to fall far enough that they cross, forcing them to not be parallel. So how could we use this thing then? How can we use the corresponding angles postulate to actually answer stuff? All right, well, let's start here with problem A. The measure of angle ECF. E over to C over to F. How big is that angle? You should observe that this is a corresponding angle with here. Bottom right corresponds to bottom right. Because we were told these lines are parallel, we know that those corresponding angles have to be the same. So this one's 70, so is that one. You're done. For problem B, we still have these parallel lines. The arrows tell us these lines are parallel. And so we want to know how big is angle DCE. Well, that's top right matching top right. The corresponding angles postulate tells us those two angles will be congruent. And we know that whenever angles are congruent, their measures are equal. That's the foundation for this. Because they are congruent, it tells us we will get to create an equation using the equal sign. 4x plus 22 has to equal 5x. And our geometry is done. Now we are back to algebra 1. Solve the equation and we've got our answer. Minus 4x, minus 4x, and we'd get 22 is equal to x. Don't stop there though, because the directions did not say find the value for x. We were told find the value for the angle. Well, our angle was 5x, so 5 times x, 5 times 22, and we're done with that one. And I want to emphasize, the only reason we are able to create this equation in the blue is because those purple arrows were there. Because we were told the lines are parallel, it allows us to do these things. Real quick one, how big is angle QRS? I want to be careful because a lot of times students say, oh, it's 118, I can see the number. Be careful. Corresponding angles will of course match. This is 118. That's true. But is that the angle that you were asked for? We were asked for QRS. We want to know that angle. And so what you'd have to recognize here with the red, we have a linear pair. They have to add up to 180, so simply subtract off from 180, and you'll get the actual answer of 62 degrees. Don't fall into the trap of assuming, well, they're equal, so therefore my answer is just going to be the number that I see. Actually stop to think about the relationships, because you will encounter problems where we do this. You have to catch all the relationships, not just one of the relationships. A piece that we'll actually see a little bit later on, and I just wanted to point it out right now. Think about what would happen if our parallel lines were cut by a transversal so that it was perpendicular. Well, because this is 90, just using a linear pair, that's 90. Going to the left linear pair and downward linear pair, we know all of those are 90s from the perpendicular. We can tell immediately then, because corresponding angles all match up. What do you know about all the angles on the bottom? They're all 90s. Really simple picture. All right, now the corresponding angle postulate was a postulate. We didn't need a formal written proof. The next three things, though, are theorems, and so we do need to have written proofs for them. We're not going to prove them all here in the video. In fact, proving them is part of the proofs are inside your homework. No fill in the blank style 2-column proofs. And here is our first one. The alternate interior angles theorem. This one, very similar in structure, tells us if we have parallel lines, then that will cause alternate interior angles to be congruent. Why? Why does this one have to be true? And so I'll help you out with this one. We would start off with, here's our picture, it's all given. So that's saying P is parallel to Q. And the next component that we're going to use, and right now I'm going to focus just on the ones in the red. Why is it that angle 3 and angle 6, so backwards, angle 6 and angle 3, why are those congruent? Here's where we're going to start. Angle 1 is congruent to angle 3 because of the corresponding angles postulate. We would also know angle 6 is congruent to angle 1. Why is it that these two angles have to be the same? Going back to our first unit, those are vertical angles. All vertical angles will be congruent. And so what we should be able to recognize then, we could put these together. 6 is the same as 1. 1 is the same as 3. You see the bridge forming? 6 connects to 1, 1 connects to 3. We can cut out the middleman and simply say angle 6 is congruent to angle 3, and that was the transitive property of congruence, which shows us exactly what we wanted to do. The alternate interior angles 6 and 3 are congruent. Therefore, parallel lines tell us alternate interior angles are congruent. Here's our proof for the alternate interior angles theorem. You'd have something similar for the alternate exterior angles theorem, which is here. If you have lines that are cut by, if you have parallel lines, it will force these alternate exterior angles to be congruent. And once again, you can refer to it with the symbolic logic like I have here. You can also refer to this by its name, the alternate exterior angles theorem. And the last theorem we have is the same side interior angles. Basically, you know all those angles we were using yesterday? Corresponding angles, alternate interior angles, alternate exterior, same side interior. Every one of those things has a theorem attached to it, and this is our last one. We saw that corresponding angles will be congruent. We saw that alternate interior will be congruent. We saw that alternate exterior will be congruent. Simply following inductive reasoning, we would say, well, same side interior must be congruent too, because that's the pattern. Unfortunately, the pattern fails. Same side interior angles will not be congruent. And we can just very, very rapidly see that. Here are same side interior. You mean to tell me that those are congruent? Obviously not. One of them we can see is acute. One of them we can see is obtuse. So one of them has to be smaller than 90. One of them has to be bigger than 90. There's no way that they can be congruent. Same side interior angles break the trend of having congruent and instead give us supplementary. Same side interior angles will be supplementary only when they come from a set of parallel lines. And so the same side interior angles theorem tells us if you have parallel lines, then those same side interior angles are supplementary. Why? Well, this is one of the things you actually have to prove this inside your homework. Why would it be true? And I'll give you the plan. I won't write up all the details here because, of course, I don't want to do your homework for you. But the basic plan is, and I'm going to say, why is it that angle 2 and angle 3 are supplementary? The plan, 1 is the same as 3 because they're corresponding. That's going to lead us to getting equal measures. Because they form a linear pair, angle 1 and angle 2 are supplementary. As a linear pair, you get the measure of angle 1 plus the measure of angle 2 will equal 180. We can then do substitution. Angle 3 replaces angle 1, which will create the measure of angle 3 plus the measure of angle 2 equals 180. And that is the definition of supplementary. That's the basic outline. We're going to use the corresponding angles postulate to get congruent angles. We will use a linear pair. That linear pair will create supplementary, and substitution finishes us off. You will need to write up the details for one of your homework problems. So how do we use these things then? Well, what is the measure of angle EDG? Well, let's start searching for a relationship. EDG is x minus 30. And I want to point out There are lots of ways that we can solve these things. There are lots and lots and lots of ways to do it because there are so many relationships. There's not one correct way. The piece that I observe right here, we've got 75 degrees. What is the relationship between those two blue angles? Those have to be equal. And I know that they're equal because we are told the lines are parallel, and parallel forces alternate exterior angles to be congruent. Well, these are alternate exterior angles, so I know that those are the same. Giving me a really easy equation to solve, just add 30, and we get x has to be equal to 105. We weren't asked to get that either. You'll notice that this problem right here did not ask us to solve for x. They just said, how big is the angle? We could have simply said, oh look, those are the same. My answer is 75 degrees, done. And you didn't need to create an equation at all. I just simply wanted to go through and emphasize there are so many relationships here that if you don't know what you're looking for, you can wind up going off on a tangent, find out a whole bunch of stuff that's true, but not actually answer the question. Make sure you pay attention to the directions because they will tell you what you're supposed to do. You can write down a whole bunch of things that are true, but if you don't actually do what was asked, you can't expect to receive full credit because you didn't do what we wanted you to do. Continuing further, clear out some of this stuff. What about angle BDG? BDG. You'll notice that's x degrees. Well, of course, I just erased the work for it, but it was helpful anyhow. We went through and solved x was equal to 105, so there, we've got that answer too. And it turns off going off on the tangent was still helpful. We can still find more information. It might be helpful, it might not. It just depends on what we encounter. One of the really cool parts about this, though, where it gets just really, really simple, at its most basic level, this entire unit is this one sentence. If the lines are parallel to begin with, then no matter what two angles you grab here, there are only two possibilities. They're congruent or they're supplementary, which means that there are only two kinds of equations you can make. They will be equal or they will add up to 180. That's it. Those are the only two things that can happen. So when we look at this and say, we want to know the size of angle ABD, we're searching for that one. Well, we don't have a whole lot of information to go on. The only two things we've got, we know that this angle is 2x plus 10. We know that angle is 3x minus 15. In the yellow, what are those? We only have two possibilities. They're either congruent or they're supplementary. Which ones are those? Are those angles that are the same, or are those angles that would add up to 180? Just looking at them, we should be able to see, oh, those are supposed to be the same. Those are supposed to be congruent. And in fact, because they are alternate interior angles, we know that's the relationship. We would have to recognize these two things must be equal. So we'll solve the equation then. Subtract off 2x. After that, we'll add on 15. And solving the equation, x is 25. Hey, we have a number that's not what we wanted. But it's the only thing we could do. The only relationship we could put in was to find this value of x. But that's helpful for us because now that we know x is 25, we could go through and say right here, 2 times 25 plus 10. 2 times 25 is 50. 50 plus 10 gives us 60. So that's a 60-degree angle. Once again, remember, whichever two angles you pick, there are only two possibilities. They will be congruent or they will be supplementary. The stuff that we've just done in blue has told us this is a 60-degree angle, and we want to know how big is that one. We'll just look at them. Are those congruent or are they supplementary? They're supplementary. Clearly, one of them's acute, one of them's obtuse. They can't be congruent. So to get the angle we want, just subtract it off from 180. And we finally answered the question. The measure of angle ABD is equal to 120 degrees. And it took kind of a lot to get us there. You needed to recognize the alternate interior angles theorem to create the equation in red. That turns it into algebra 1. So you have to use your algebra 1 skills to solve for x. And one of the students just caught me and corrected me because, well, my brain was stupid and I didn't see the angle right. I don't know, my brain just wasn't thinking straight. The angle that we were supposed to be going for, ABD, would have been A over to B over to D. And so we were searching for that angle. And we found that one right here with the blue, so it was 60 degrees. I don't know why I thought we were going for a different one, but I was thinking BDE, or I don't know, my brain was just silly and dumb for a minute. Sorry, guys. Still worth noting, though, in order to get this piece, we still needed to do all the stuff in red. We had to recognize the alternate interior angles theorem. We had to create the equation, we had to solve it, and we had to substitute back in. And here's the last one that we'll do. Do we have any guitarists in the room? Welcome to a guitar. We know that all the strings on a guitar are parallel. We know each of the frets are parallel. And depending on the specific structure and design, you will have parallel lines for the frets. All three frets can be parallel, and then you can run the guitar strings at various angles. Well, we want to know how big are x and y. So what relationships do we have? And to help make this a little bit easier, I'm going to blow up the picture just so that it'll be bigger and give us a little bit more space to look and see and work with. Well, first thing I'm going to note, right here I've got a 60-degree angle. And remember, every single pair of angles only have two options. They're either equal in measure, or they will add up to 180. Just look at the picture and tell me, where are all the angles that are the same as this 60? Well, of course, vertical angles would be. And then we would have corresponding angles and corresponding angles. All four of those in the red have to be congruent. And we know they're congruent because they're sitting along this same transversal. We have the parallel lines We have the transversal. Those four angles in red are the same. That will allow us to create an equation. 5x plus 5y has to be 60 degrees. By itself, that's not going to do a whole lot for us. However, we've got another set. This is a different transversal. With a different transversal, we have different angles. 55, 55, corresponding angles. All of these in the blue have to be 55 degrees, which would allow us to then identify 5x plus 4y is equal to 55 degrees. And we've now created an Algebra 1 problem. Solve this equation. Perhaps the most straightforward way to do it is to recognize that we have 5 and 5. So we could subtract the bottom line off of the top. 5 subtract 5 cancels. 5 subtract 4 would give us 1y. And 60 subtract 55 would give us 5. And so there we now know that y is equal to 5. That's one of the things we were asked to get. Now let's go back and get the other one. And I'm choosing to use this top line here. 5x plus 5y will equal 60. So 5x plus 25 is equal to 60. We could subtract off 25. 5x is equal to 35. And dividing by 5, we get x is equal to 7, giving us the second thing that we were looking for. And finally, we are done. As I've noted several times before, it's very, very common in geometry that you will look at the picture, recognize the thing that you are supposed to recognize. That's where the geometry comes into play. And once you recognize the characteristic, once you recognize the theorem, you can create something from Algebra 1 and turn it back into your earlier class, use those skills, and actually answer the question. This was another example where we turn it into a system of equations and solve that. Just last little emphasis, this is an example where we use the theorems. Each one of these where we're solving the problems. This is our objective where we use the theorem. The two things we need to do are to write up a proof and to use these theorems to create the equations as we just were.